Hello everyone. Today I'm going to be discussing the topic of couple moments. So here we have a problem that it has a rod looking shape and it has two different couples. So what a couple is that they're forces that have the same magnitude but in different direction. So if you look at the yellow forces, the two yellow forces, the one that's right here and here, you can see that they're both 75 pounds, but they're in opposite directions. We also have another couple moment right here, these two red ones. They have the same magnitude, which is 100 pounds, but they're also in the opposite direction. So these forces, they often can apply torque on the object. So here, if you make a pivot point right here, you can imagine that this force will cause the object to rotate in kind of like a counterclockwise motion, while this force will cause a clockwise motion. So here, this problem is asking us to find the resultant moment that's caused by all these vectors or forces. So to get started, the first thing that you always want to do is to make a pivot point. So a pivot point is gonna be kind of like your origin on the object. So to make this problem easier, I'm gonna choose my pivot point to be right here. So this is gonna be my pivot point. So all forces will be causing a rotation around this pivot point. You don't need to have the pivot point right here. You can make it right here. You can make it here. You can make it here. You can make it anywhere, but it's the easiest way to solve this problem is by doing it here, since you know the distance around this point from all forces. So, like the usual, before you start any of these problems, you have to always say that the sum of the torques is the torque caused by the couples. So I'm gonna call this torque 1 and this one torque 2. So torque 1 plus torque 2. So the sum of the torques is now equal to. So before you start writing down the equation, you always want to draw the x and y components of all vectors that you have. So here, if you were to draw a line of action, you would have this as the y component and this is the x component. Similarly, here, if you were to draw the line of action, you would have a y component right here and an x component right here. So let's focus. So let's focus on this object right here first. So here you can see that the x component is going to go through the pivot point, meaning that it won't cause torque. If you have a force that goes through a pivot point, it will not be causing torque. So here we can ignore the x component and we can only focus on the y component. So the y component of the 75-pound force would be 75 pounds sine 35 degrees times the distance between the y component and the pivot point. So here you can see that it's 5 pounds. So times, 5 feet times 5 feet. Now, you gotta think, will the y component cause a clockwise rotation or a counterclockwise rotation? So I'm gonna choose my counterclockwise rotation to be as positive. So any force that causes a counterclockwise rotation is positive. Any force that causes a clockwise rotation is negative. So you can imagine that if you're pushing a rod right here with a force that's going downward, and this is the pivot point, it will go in a clockwise rotation. So since clockwise is my negative, I'm gonna add a negative sign right here. So we're done with this force right here. Now let's go to the couple of that force. So it's this force that's right here. So you also have a 75 LP. And now if you draw the components of it, you're gonna have a y component right here and an x component right here. So you can see that the y component is gonna go through the pivot point, meaning that it won't cause any torque. So we're only gonna take the x component since the x component does not go through the pivot point. So the x component will be 75. Here, let me write that a bit neater. 75 LP cos 35. So now you gotta see, first you gotta see the distance between the x component and the pivot point. So you can see that it will be 6. Because if you were to draw the force right here, you can see the distance from here to the pivot point is 6 feet. So this times 6 feet. Now, again, you gotta think, is this component of the force, is it gonna be causing a clockwise rotation or a counterclockwise rotation? So here, draw the rod right here. Again, this is your pivot point somewhere here, and you're pushing it with a force that's horizontal. So you can imagine that it will go in a clockwise motion. But since clockwise is our negative, we will need to include a negative sign right here. So again, you can make clockwise your positive or negative, it doesn't matter. At the end, you will get the magnitude, but if you chose the wrong direction, you would just get a negative sign. So you would know that the rotation is going to be in the opposite direction that you originally chose as positive. So now, we're done with the yellow forces, now let's go to the red forces. So this is our first force right here. So again, if you were to draw a line of action right here, and you were to draw the forces on it, acting on it, so this is your y, this is your x, you can see that the x, if you were to stretch it out, it will go through the pivot point, meaning that it won't cause torque. So now all you're left with is the y component. So the y component will be 6 over 10 times 100 pounds. So 100 pounds times 6 over 10, since this is the vertical component of the force. And then the distance between the vertical component and the pivot point is 5 feet. Sorry, it's 3 feet, not 5 feet. So it's this one right here, 3 feet. And now you want to draw the rod right here. And the force is going to be going something like this. So you can see that this one will cause a clockwise rotation. Since the rod, you can imagine that it will move in kind of like a counterclockwise rotation. So here we have positive sign. Now, finally, the last force that you're going to be looking at is the couple of this red force right here. So you extend the line of action. You draw the x and y components. You can see that the y component is going to be going through the pivot point, meaning that it will cancel out, so it will not cause torque. So you only need the x component of this force. So the x component will be 8. And if you're wondering, I got the 8 from right here, since this is the x component of that force. 8 over 10. The 10 is the magnitude of the hypotenuse, times 100 pounds. And then the distance from the x component to the pivot point is 4 feet. So times 4 feet. And then finally, you draw again the rod right here. This is your pivot point right here. You're going to be applying a force in that direction, so it's going to go something like this. So you can imagine that the rod will go in a counterclockwise rotation, meaning that it would cause positive torque, according to our original plan, being counterclockwise is positive. So here it will be positive. So this is overall your equation. So if you were to put this on your calculator, you would get a final answer of approximately negative 84 pounds, not feet. So again, you can see right here that we got a negative sign. So this means that actually the couples are causing this force to go clockwise, not counterclockwise. So our original assumption was wrong, but Overall, we now know that it's actually going to go counterclockwise. I meant clockwise. So if you were to make clockwise as your positive from the beginning, then here you would have got a positive number. And you wouldn't have to worry about, thinking which way is it going. But since we chose counterclockwise as our positive, we get a negative number, meaning that we go in the clockwise direction. Thank you for watching, and I hope you learned something from it.